All right, welcome everyone. Today, we're going to pull back the curtain on one of Python's most powerful and, let's be honest, kind of mysterious features, these so-called magic methods. Let's dive in and see how you can really take control of your objects.
So if you've written even a little bit of Python, you've definitely seen this, __init, and you've probably wondered, what's the deal with those weird double underscores on each side? I mean, they're not just there for decoration, right? They're a signal that something special is happening under the hood.
Well, they're called Dunder methods. And yeah, that's just a fun little shorthand for a double underscore. But you'll also hear them called magic methods. And the reason is you almost never call them directly. Instead, Python just calls them for you automatically when you do something else, like use a plus sign or print something. It's that automatic response that makes it all feel like magic.
So, why does Python even have this whole system in the first place? What's the point? Well, as it turns out, they are absolutely fundamental if you want to make your own custom objects behave in intuitive, natural, Pythonic ways.
Think about it like this. When you create a new class, Python doesn't just automatically know what it means to add two of your objects together. It doesn't know how to figure out their length, or even how to display them in a way a human can understand. Without Dunder methods, your objects are just boring boxes, generic containers for data with no special behaviors.
And this right here perfectly illustrates the problem. Let's say you create a person object and you try to print it. You get this. I mean, what even is that? Sure, it tells the computer its class and where it lives in memory, but for a human being, it's completely useless. We need to tell Python how to represent our object in a way that actually means something. And that brings us to our very first set of spells. These Dunder methods are all about giving your objects a voice, controlling how they get represented as strings in different situations.
Okay, now this distinction is super important. You've got __string, and you've got __repr. Think of __string as being for the end user. It's the nice, clean, friendly output you want when someone uses the print function. __repr, on the other hand, is for you, the developer. Its goal is to be a totally unambiguous, official representation that's incredibly helpful for debugging. So, one is for readability, the other is for pure clarity.
All right, so our objects can introduce themselves properly now. That's a great start. The next step is to teach them how to interact with the world and with each other, just like Python's built-in types do.
So, let me ask you this. Imagine you've created a custom class, maybe for a shopping cart, and you want to add two carts together to combine their items. What do you think happens if you just use the plus sign?
Yep, you get this. A big old type error. Python basically throws its hands up and says, look, I have no idea what you mean by add for these two things. It's not a mind reader. We have to give it the instructions.
And the way we give it those instructions is through a concept called operator overloading. Now that sounds complex, but it's actually really simple. We are just giving a new meaning, or a new job, to an operator like the plus sign. By implementing the __add Dunder method, we're explicitly telling Python, hey, whenever you see a plus between two of my objects, this is the code I want you to run. And it's not just for addition. You implement __len, and suddenly the built-in len function just works on your object. You implement __equals, and now you can compare two of your objects with the double equals sign. You're basically giving your custom objects the same superpowers that built-in types, like lists and strings, have had all along. All right, now for something really cool. Most of the Dunder methods we've looked at help an object act like a piece of data. But what if you could make an object act like a function?
This is where the _call method comes in. It's kind of mind-bending at first, but by defining this one method inside your class, you can take an instance of that class and then call it with parentheses, just like you would a normal function.
And trust me, this isn't just some weird party trick. This is a total game changer for advanced programming. Think about AI frameworks. A model layer is often an object that holds state, like weights and settings. But you can also call that object with your input data to get a result. That's _call_inaction. And it makes for incredibly elegant and efficient code.
Okay, we've covered a lot of ground. So let's slow down and consolidate all of this into a practical toolkit that you can start using in your own code right away.
By really understanding these methods, you've moved past just using Python to actively shaping how it works. You're not just a user of the language anymore. You're starting to become an architect. You literally have the keys to the magic.
So here it is, your Dunder method cheat sheet. Honestly, if you can master these 7, you'll be able to handle about 90% of the real-world situations you're going to face. From construction with _init to comparison with _equal, this is the core set you absolutely need to know. But, of course, just because you can do something doesn't always mean you should. It's really easy to get carried away. So, you know what they say, with great power comes great responsibility. How do you use this power wisely?
The rule of thumb is actually pretty simple. Only add a Dunder method if it makes your code more intuitive and easier to read. Does it make logical sense for your vector object to be added to another vector? Then yes, for sure, implement Dunder and. But don't do it just to be clever. Always prioritize clarity over complexity.
So, we've unlocked the secrets. It turns out Python's magic isn't really magic at all. It's just a really well-defined interface for making your own custom objects first-class citizens in the language. The real question now is, how are you going to use this knowledge to make your own code clearer, more intuitive, and way more powerful?